Assalamu alaikum wa rahmatullah. Welcome to the part 15 of our video for the first material. Okay, we will begin by looking at example 3.8. A stone of mass 0.5 kilogram is thrown vertically upwards with a velocity of 10 meters per second squared. Find A, the potential, the potential energy at the greatest height h and the value of h. B, we should find the kinetic energy on reaching the ground. Again, assume G equals 10 meters per second squared and neglect air resistance. Okay, if you look at the problem again, there is a bit of an anomaly. They gave us the mass and the velocity, which are the details we need to get the kinetic energy. But they are asking us to get the potential energy. Why? The reason being that because there is conservation of mechanical energy, all the kinetic energy will be converted to the potential energy. So if we get the kinetic energy, that amount that we get will eventually be the greatest potential energy, the maximum potential energy. So we are going to use in the solution, you see potential energy at maximum height is mgh, and this is equal to the kinetic energy because we obtain the potential energy from this kinetic energy. So you go ahead and get the kinetic energy. Have your mass is 0.5 and the velocity is 10, so you square the 10. You take your calculator, 0.5 times another 0.5 times 10 squared will give you 25 in joules. Now, um, because to get the greatest height, to get that h, because they say we should get the value of h, to get the value of h, remember that mgh should be equal to half mv square. You equate the two of them because they are equal. So this should cancel this, the mass cancel. You you divide both sides by g, so your height will be v squared over 2g. Your v is 10, you square it. Your g is also 10, so 2 times 10 will be 20. 10 squared is 100, divided by 20 will be 5, so the height is 5 meters. Okay, then what they said in B is we should get the kinetic energy on reaching the ground again. Well, when from the beginning, at the point of throw, it has kinetic energy, and that kinetic energy we got it as 25 joules. Upon reaching the maximum height, all the energy is converted to potential energy. When it comes back to that point again, the potential energy is reconverted back to the kinetic energy again. So the amount will still be the same since there is conservation of energy. So our value will remain 25, the 25 joules that we calculated here. They say the kinetic energy on reaching the ground again will have the same value, 25 joules, since mechanical energy is the same, provided no energy has been lost due to air resistance and friction. And interestingly, we are told to ignore or neglect air resistance. Okay, here is the next problem. The next problem says a body of mass 2 kilogram falls from rest through a height of 20 meters and comes to rest having penetrated a distance of 0.5 meters into sandy ground, meaning when it reaches the ground, it penetrates to the ground from the point from the point it was released to the ground level. That has a height of 20 meters, but then after reaching the ground, it penetrated a distance of 0.5 meters into sandy ground. We should calculate the average force exerted by the sun in bringing the body to rest. Okay, this average work is done in bringing it to rest. Okay, the ground has done work in bringing it to rest, and this work should be equal to the kinetic energy upon reaching the ground. And remember, the kinetic energy upon reaching the ground is equal to the potential energy at the maximum height. So what we will do now is to get that energy, mgh. So 2 mgh, 2 is the mass, and then g we know is 10, and h is the height, 20. This will give us 200 joule. It means its kinetic energy upon reaching the ground is 200 joules. So the sun will have to do work equal to this value to stop it, and the work done is force times distance. So from there, we know that our distance is 0.5 distance into the sun, and this is the force exerted by the sun. So the work done, we say, should be equal to this before it will be stopped. So 0.5 times F will be the work done. This is the distance times the force that we don't know is equal to this value, 400. When we divide both sides by 0.5, we will get the force at 800 Newton. Next, example 3.10, a ball of mass 2 kg falls from race from a height of 200 meters. Calculate its kinetic energy after falling a distance of 50 meters. Neglect air resistance and take G equals 10 meters per second square. Okay, here is what is happening. At the highest point, its height from the ground was 200 meters. Then it moved from that point to a point 50 meters away from that point, which means its distance from the ground will now be 150. So we have to get the total energy at the highest point, which will be mgh, and the mass is 2 kilogram. The g we know is 10, the height 200. This is its energy. Because it was at rest, kinetic energy was 0, so the total energy will be the potential energy at that point. Now, when it reaches a point 50 meters below, its height from the ground will be 150. That is why they say E sub P at 150. Potential energy at 150 meters will now be mgh. Mass is 2 kilogram, g again 10, and the height is 150. You see, this means that its potential energy dropped from 4,000 joules to 3,000 joules. Now this means it has dropped by 1000. Now this 1000 has been converted to kinetic energy. It means its kinetic energy at this point is 1000 joules. So that if you add 1000 to this 3000, you will get the 4000 back. So they said, I've just gave you the answer. 1000 joule, you divide by 1000, you get 1 kilojoule. But here is the analysis. Total energy at 150 meter at that point will be potential plus kinetic. But we know that potential plus kinetic should give us our 4000 joule back, the initial, because energy is neither created nor destroyed. So now we know our potential energy at this point, so we can write it there, 3000. So if we put 3000 plus the kinetic energy at that point that you know should be equal to the total energy 400. So it means your kinetic energy should be 4000 minus 3000, which is 1000. Then you divide both sides by 1000 to change the joule to kilojoule. This will give you 1 kilojoule as the answer. Okay, in the next video we will explain power. Thank you for watching.